that's for a super user, but for anybody else, you just put in your name and you don't need a password.
Same for air calip, right?
Yes.
Okay.
Just for a user. Then you have acquisition. You have a number of different methods. We're going to make a new method. Okay, we're going to call this normalization.
I'm sorry, did you see anything?
Yeah, it's fine. Okay, so we're going to have all the parameters here. We're going to let it count for a minute. The processing options, you can have it maximum time or maximum count. What this is useful for is if I want this to either count for 1 minute or 10,000 counts, whoops, or 10,000 counts, whichever comes first. So it'll count, start, and it'll count for either 1 minute or 10,000 counts, whichever it comes first. Okay, it's kind of a neat feature for low activity samples. You can have it automatically print a report if you want to. The starting position, you can either have it start home, next tab, or the current position. Valid format, okay.
Do you know what tops are? The tops are those black little spots?
Yeah, we went over that. So I often use current position and take care of it myself. Over here, the number of channels, that's basically, you've got 20 centimeters. That's how many sections or bins you break that 20 centimeters up into. 256, 512, or 1024. 99% of the users use 256. But if you want more resolution, you can have it be have the higher number of channels. That comes at a cost of sensitivity, because now if you have 10,000 counts, you're dividing it over 1024 bins versus 256. So everything's going to kind of fall down. The collimator, the width, it could be 2, 4, 6, 8, or 10. You only have 10 millimeter collimators. You have high efficiency or high resolution. That's in the video, we went over that. This is the high resolution collimator, and the other one's the high efficiency collimator. Electronic resolution, this is a pulse height rejection thing that again increases resolution. You can either have normal, moderate, or high. 99% of the people keep it at normal, but in some instances you can change the electronic resolution and it'll help the resolution. But this again comes at the cost of sensitivity, because now what you're doing is you're throwing away pulses that you don't like, and you're narrowing in on a smaller band, and you're throwing a lot of stuff away. Okay, corrections. There's a couple corrections that you can have. Normalization, what that is what you do to correct for normalization is you take account of this to show how the detector is non-uniform, and then you can apply that acquisition to future acquisitions, and what it does is it calculates correction factors, saying it's a little high here, a little low here, a little high here, a little low here,